Hi everybody, this is going to be our note for 4.3 on the quadratic formula. The good part is if you've already learned the quadratic formula, this lesson is a bit of review. If you haven't learned about it before, it's pretty straightforward. Normally, when we want to find the x-intercepts, we had to use things like common factoring, or sum and product rule, or decomposition, or that x trick we learned about. But sometimes we learned that it's just not possible to factor some things. So we need a better way to factor, or to find the x-intercepts if we can't factor. Because again, we did some examples where in our homework and in our worksheets where it's like, oh, we can't factor this. So it's not possible. So what do we do? Well, we have to use this equation, the quadratic formula. Now the really good part about this is if we were in school, you would have to memorize this. If we had a test or a quiz, I would not give this to you. You'd have to know it off the top of your, or off the, you have to know it by heart. You have to memorize it. But since we are not at school, when we do assignments, you just have access to this. So you can look at this whenever you want when you're doing your assignment or your homework. So please, I ask you when you're doing your assignment for Unit 4, please don't make mistakes with this. Because, again, you don't have to memorize it. If you're not sure about it, you can literally just write it at the top of your assignment page or have it right beside you when you're doing these questions. As long as we're able to figure out these letters, A, B, and C, we'll be able to use the quadratic formula. So some key points to help us when we're doing when we have to use our quadratic formula. So first off, to use it, we have to have it written in standard form. And if you're like, what's standard form again? Well, that's the thing we just had up here. And it's this where everything, there's no brackets, ax squared plus bx plus c, everything's on one side. Equal to y or equal to 0. It's always like this, ax squared plus something x plus something without x. So it has to be in standard form. All quadratic equations of the form this, our standard form, can be solved using the quadratic formula. So it will always work to find the x-intercepts. Again, we'll get to that in a second, but 99% of the time it'll work. If it's possible to find x-intercepts, you'll be able to find them using the quadratic formula. There's one case where you won't be able to, which we'll see at the bottom. The quadratic formula is derived from completing the square, which is why they're in the same unit together. So we got this from completing the square. I'm not going to ask you how did they get that. It's not really important for you, to be honest. You just have to know how to use this equation. It just allows us to calculate the roots or the x-intercepts or the solutions. All of these things all mean the same thing. It lets us find the x-intercepts without having to graph or use like factoring. And the quadratic formula sometimes leads to a negative number underneath the square root sign. So this is our case. If I have a negative number underneath that square root sign for the quadratic formula, so if all of this is a negative number, well, we can't actually have a negative number underneath the square root. So if there's a negative here, then we're going to get no real roots or no x-intercepts. It's a bit tricky to realize, but you'll notice that you can't actually square root this on your calculator. It'll say error. So we're going to do some examples now that see this. But as long as we keep this part in mind, the rest is pretty straightforward. And as long as we know our letters from our standard form, we'll be able to put them in the equation and solve for the x-intercepts. So let's just look at an example. We'll look at an example where we're going to use factoring, the sum and product method first, and then we're going to use a quadratic formula. And that's just to show you that it doesn't matter which method you use. We've been learning all of these methods so that you can choose the right one for when you want to. So factoring in this case is going to be much faster than the quadratic formula. But if this was a test or a quiz and I needed to find the x-intercept and I just, 10 minutes goes by and I can't factor this, then just use this. It'll save you a lot of time and grief. Just have to make sure your BEDMAS and your algebra is good in order to get the answers for this. So our first equation is x squared minus 8x plus 12. I'm just going to write that over here. So with our factoring, what we did last chapter, we said we need to think of two numbers that multiply to give us 12, and they add to give us negative 8. So then we think of our factors for 12. Well, I know it's going to be like 1 and 12, 2 times 6, 3 times 4, and then like 4 times 3, but like that's just the same as this, so I'm not gonna count that one. But it's still factors. So if I multiply these numbers together, these pairs, they're going to give me 12. And then I have to add them together to get negative 8. Well, I know that if it's got to add to give a negative number, and they multiply to give a positive number, that both numbers have to be negative. So if I make these both negative, which two are going to add up to give me negative 8? Well, it's going to be these two. These two pairs multiply to give me 12, and they add to give me negative 8. So these are going to be my factors, x minus 2, x minus 6. And we should be pros at this now because we did that last chapter. So our x-intercepts now, what we would normally do is we would just get these factors, make them equal to 0, and then solve for x. So that's how we'd find our x-intercepts with factoring. So find two numbers that multiply to 12 and add to negative 8. We said those numbers are negative 2 and negative 6, so we get this equation. And then I did all that stuff here. So that's it by factoring. Now I'm going to do the same thing with the quadratic formula. Notice my equation is this x squared minus 8x plus 12. So what is my a value? Well, the a value is always the number in front of the x squared. If I don't see a number there, it's got to be a 1. The b value, is always the number besides just the x, not the x squared, just the x, so it's going to be negative 8. And the c value is always the one without any variables, so it's going to be 12. So I know my a, my b, and my c. I'm going to put them into the quadratic formula and then just follow my BEDMAS. So I always start by writing out the equation. That way I know when I put the numbers in, I'm going to put them in correctly instead of skipping that step, because a lot of students will lose simple marks like that because they forget the equation or they write it out incorrectly. So I write it out again and I double check that I've written it out correctly so that when I put my numbers in, I have less chance of error. So one trick here is that we have negative b here for our equation, and we have negative 8. So I'm still going to substitute the b with negative 8. So we're going to get negative 8 plus or minus the square root of, well, b we said is negative 8, so negative 8 squared in brackets because the negative 8 exponent applies to the negative 8, not just 8. So then I'm going to put 4. We said our a value is 1. We said our c value is 12, all over 2 times a, which is 1. So I literally just got a, b, and c and substituted them in here. So I'm just to follow our algebra, we're just going to follow our BEDMAS. So I'm going to start here, 2 negatives, make a positive. It's going to be positive 8 plus or minus the square root of negative 8 squared is 64 minus 4 times 1 times 12 is 48, all over 2, because 2 times 1. So I just did my multiplication and my exponents in the same step, because the exponents happen here and then multiplications happen here separately from the exponents, so I just did them all in one step. But normally I would do this first, then I would do these, and then this is kind of multiplication or just simplifying, or part of simplifying, so I could do this together too. And then we have to remember that inside the square root sign, it's like there's brackets there. So we have to solve what's in the square roots first. So 64 minus 48 is 16 divided by 2. And then we treat this like an exponent. We're going to do 8 plus or minus 4 divided by 2. So why do we have this plus or minus here? Well, remember we have a square root. So when I take the square root of a number, in this case it's 4, it could be positive 4, because if I times positive 4 by itself I get 16. And if I get negative 4 and times it by itself, it's also 16. So once I get to this point, I'm going to get two different answers here. One for when it's the positive, and one for when it's the negative version. So positive, negative 4 here, I'm going to separate this to positive 4 here and negative 4 here. So after we solve this, we get 12 divided by 2, 4 divided by 2, 6, 2. So notice our x-intercepts are 6 and 2, the exact same as what they were over here. So we can use this method as opposed to this method, but this method, if you know how to do it, is much faster than this one. But this one's our foolproof way. If I can't factor it, if I don't know what to do, if I'm doing a test and I've spent like 20 minutes trying to factor it, this is our foolproof way. And if you're like, well, why didn't you teach us that earlier? So for our last test, I wouldn't have to do this. Well, you still have to know how to do this. I still want you to be able to do this. But this is now another method if we can't do this. But if you're continuing with math, the factoring stuff is very important. So naturally, you've done this enough times. We're just going to practice this again and again and again. So first thing I'm going to do is write out what my A, B, and C are. What do I know? A, B, and C. A is always beside the x squared, 2. B is always beside the x, negative 3, because the sign is always in front of the number. And C is negative 2. And then I write out my equation. Again, you should write it out, because otherwise you might make a mistake. Also, it's good, kind of good habit to do that. Also, again, you don't have to memorize this, so you should just be able to look off of something and copy it out, and it should take you about 10 seconds to do. So we sub in our values now. We have negative 3 for B, so again, we're going to see negative 3 plus or minus negative 3 squared minus 4. Oops, so we said A is 2 and C is negative 2. All over 2, 2. So I get plus or minus this. Negative 3 squared is 9. And the key here is that I have a negative 4, because it's subtract 4, but this is still a negative. You can think of it as a negative 4. And I have a negative here. So I'm going to keep the negative here just to show you that when I multiply these numbers, 4 times 2 times negative 2, that's going to give me negative 16. So the signs here are really important. If you want to, multiply these first, and then with the negative you have there, then you can simplify it. You can also think of it as negative 4 times negative 2 will give me positive 8, and then positive 8 times 2 will give me positive 16. 9 plus 16. So if you wanted to go straight from this step to this step, you can, but how do we get plus 16? Well, that's the reason why we get it. So times 4. So then we just do the stuff underneath the brackets. We add those together, we get 25 divided by 4. Square root of 25. Using a calculator, it's going to be 5. And then we have the plus or minus sign here. So now I'm just going to do one for x equals 3 plus 5 divided by 2. And then x equals 3 minus 5 divided by 2, which is equal to 8 over 2. So my x-intercepts are 4. Sorry, you can see what I was writing. So 3 plus 5 divided by 2 is 8 divided by 2, which is 4. And then 3 minus 5 is negative 2 divided by 2. So negative 2 divided by 2 is negative 1. So my x-intercepts are 4 and negative 1. So you're like, oh man, that's a lot of work. It's a little bit of a calculation. I still think it takes longer than if you were to factor it. But again, what if we can't factor? Well, then we have to use these methods. So let's just do one more. Well, two more. One with a word problem, but one more kind of basicer one. More basic one. Basicer isn't a word. So A is equal to, in this case, 20. B is equal to 27. And C is equal to, remember, it has to be in standard form. So we actually need to move the 14 that's on this side to this side. So it looks like 20x squared plus 27x plus 14 is equal to 0. Because now this is in standard form. Now I can get my numbers. So we're going to get that. So I'm going to get my quadratic formula. And I'm just going to sub in my values. If you want, you can pause the video, try doing it yourself, and then check your answer with me. Or if you just want to just follow along, you do that too. So I'm going to get 27 squared minus 420 divided by 2 times 20. And then I'm going to do this. X is equal to negative 27 plus or minus 27 squared is 729 minus 4 times 20 times 14 divided by 40. So now what do we do? Sorry about that. All I did was fill in the numbers anyway. So what am I going to do now? I did this. I'm going to multiply these now. Negative 27 plus or minus 729 minus 1120 when I multiply those all together. And then I'm going to get negative 27 plus or minus negative 391 over 40. So this was our example where we have this now. We have a negative under the square root. If I have a negative under the square root, we said on the first page there are no answers or no x-intercepts. And just by looking at the equation, I can tell you that the graph is going to be like this probably, above the x-axis. So remember, if I get a negative under the square root, there's going to be no x-intercepts. But again, you have to be careful with the sign there, because it's very simple for a question like this one where we have two negatives to also give us a negative under the square root if we're not careful. So make sure you're following your BEDMAS and make sure you're following your rules for multiplying positive and negative numbers for this one. Alright, so last question, we have a word problem, but you're going to see that it's going to be the same kind of deal. We're just going to be using the quadratic formula here. So the profit of a school drama production is modeled by the quadratic function this, where p at x, or the y value here, p at x is the profit in dollars, and x is the price of tickets, also in dollars. So the question even tells us use the quadratic formula to determine the break-even price for the tickets. So if you're thinking like, oh, what does that mean? Well, here is my equation. I know it's going to be a parabola because it's quadratic. And I know it's going to open downwards because that a value is negative. So I know it's going to be something, I'm just going to just sketch it. It's not going to be accurate at all. I'm just going to guess it's going to be something like that. Because it opens downwards. And what they mean by what is the break-even prices, well, that's what happens when the profit is p at x is equal to 0. If it's break-even, that means they haven't made any money, but they also haven't lost any money. So we're trying to figure out when is p at x equal to 0. Well, in p at x, that's our y value. Remember, this is our y value. When this is equal to 0, that's when we have our x values here. So what we're trying to find here for the break-even prices is just the x-intercepts. Because if we solve for x, we'll get the price of the tickets in dollars for when the profit is 0. So all we're going to do is we're going to outline our numbers. We're going to do part A here. We said A is going to be equal to how much? Negative 60. B is going to be equal to 790. And C is going to be equal to negative 1,000. Just based on my equation here. And now I'm just going to do my quadratic formula and just substitute the numbers into the equation. So I'm going to put in my numbers, negative 790, this, minus 4, negative 60, negative 1,000, oops, 1,000. So we see that there's going to be kind of 3 negatives in here. So we just got to check, when I do all the stuff underneath the square root sign, am I going to get a negative underneath it? So I'm just going to keep going with my calculations here. And if you need to pause the video to catch up, that's okay. I'm just following BEDMAS here. 790 squared is 624,100, and then this side is going to be minus 240,000, all over negative 120. Again, if I'm going too fast, please pause the video, but all I'm doing is I first put the numbers in for the letters, and I'm just following BEDMAS. Exponents, and I multiplied these all in the same step. Doing the inside of the square root sign now, I get negative 790 plus or minus. When I subtract those two, I get 384, 100, negative 120. And then x is equal to negative 790 plus or minus the square root of that, which we're going to get a decimal, which is okay. We're allowed to have decimals here. I always go to 2 decimal places. Minus 120. Alright, so then we have most of it now. We just have to do our thing where we divide it into 2 different parts. X is equal to negative 790 plus 619.76 over negative 120. And then x is equal to negative 790 minus 619.76 all over negative 120. So then you would calculate this on your calculator, negative 790 plus this divided by this. You're going to get 1.42. And if you do this side, you're going to get 11.75. Sorry, a bit of an edit there because I thought I made a mistake, but it all worked out nicely. So these are our 2 answers for this. So there are actually 2 prices where they could break even. Therefore, they could break even if they charge $1.42 or $11.75. Now, question B says, at what price should the drama department set the tickets to maximize their profit? We've seen maximize and minimum, or like minimum and maximum before. So we're talking about maximum here. What we're talking about is the highest point, the vertex. So if I'm looking at my parabola here, then when I know the maximum profits, well, that's got to be the vertex of this parabola. That's the maximum amount of money they could make for their music or for their drama production. So it's going to be like that. So that's going to be their highest pay, the vertex. So I have my x-intercepts. So all I need to do here is I need to find the axis of symmetry, which again is the middle part between those 2 x-intercepts. So I'm just going to get my x-intercepts plus 1175 divided by 2. I'm going to get 13, 17. Again, I'm just rounding to 2 decimal places because we're working with money. And then we get 6.585, which is going to round to $6.59. So this would be the maximum, or this would be the price of tickets to give the maximum profit. Therefore, $6.59 would give max profits. So we're just practicing using this. You get your letters, figure them out from standard form, which they give you. In your homework, you might have to like expand things. You might have to put it from factored form to standard form and then use a quadratic formula. But as long as you get it to this form by expanding, or like we've done in the past, figure out what A, B, and C are, put them into your equation, and then solve for the 2x values, one for positive, one for negative when you're doing it here. And if we get a negative inside the square root, there is no answer. So your homework's at the bottom. Again, I have office hours if you want extra help. If you have questions, please let me know and we can work something out. Thanks for your time.